So here's 6A, question 2. I gotta find the screen. There we go. All right, so we had a big, massive graph where it told you areas in there. And these were like the x values at x equals 3, 6, 8, and 9. Some other important tidbits that it gave you. It told you the original function value at 6. You can see that's not the same on the graph because this graph is the derivative, so that's really important. And then they give you g here. All right, so when they're looking at this first part A over here, they're just saying, hey, you know, what is the change in this function from 0 to 9? They're just asking, how does it change? So the only thing you need to know is anything under the x-axis is negative, anything above the x-axis is positive. Therefore, you're going to take 12 minus 10 plus 5 minus 1 equals what? 6? Good. Lovely. The harder part is part B. For part B, you have to come up with an expression for the actual value. This tells us how much this function would change, because when we integrate the derivative, we would get the function from 0 to 9. That's what this represents. But before we know the actual value, this tells us the change. We need to know at least 1 point. 1 point on that value or on that graph as a starting point. So you have to start from 6. The expression we're looking for, we know what f of 6 is. And then we just have to look at this and say, oh, you know what? I'll integrate it from here. That will give me the exact value of f anywhere. You know, and another way of writing that, obviously, you could put in 7 right there. 7 plus. And that is the expression that they're looking for. But ladies and gentlemen, there are a couple other things to look for. We need a min and a max. So when we're going forward, it's not hard to say, oh, from 6 to 8, it went up 5. Here's where it's really helpful to write down what all of these key values are. And the reason for this importance is we're looking to see what are the values at all of the critical points. And since it's on an interval, on the lower and upper bounds. So critical values are anywhere the derivative equals 0, like 3, 6, 8, and 9. Don't forget to include 0, because 0 and 9 are those boundaries. It might be the highest or lowest point on those boundaries. So we need to find these. It's given up top that f of 6 equals 7. Finding it at 8 isn't bad, because the integral from 6 to 8 is positive 5. And then when I go from 8 to 9, the integral is going to be 1 smaller. Where you have to be careful is where you go backwards. If you plug a 3 in here, don't for a minute think the integral from 3 to 6, or excuse me, from 6 to 3 is negative 10. You will need to, for some of these, rewrite it as a negative and flip those signs, because maybe the x value you're looking for is a little bit smaller. So from 3 to 6 is negative 10, but really that means minus a negative 10. That was 17 right there, and at 0, whoo, from 3 to 0. Well, anyhow, we've got those values there. We now have our min and our max. Please, you do not get full credit unless you tell us the x and the y coordinate. Whoops, that is the maximum. The minimum is actually at 0, 5. I am a fool. By the way, part C is down there because that's just a waste of time. That's way too easy. Let's move on to D, which is a challenge. Or is it? I have an idea. You know what we're not very good at sometimes? Finding basic rules like the chain rule when they're not using actual equations, but they're using symbols like f and g of x. This is just the chain rule in reverse, use substitution. If you let g equal u, and you realize that that is x squared minus 1, take the derivative and solve for dx with a little bit of simplifying that new equation. That new equation is much easier to solve. Please note how the limits changed when I went from x to u. And now we just need to plug in numbers, which we have over here, we already found.